one of our previous video, we have taken the Quantos example to understand the hypothesis testing. Now it will be better if we had taken here another example to understand. So I have taken here more complex example to better understand. So in example 1, in one of our previous lectures, we have taken the Quantos example. We have taken the Quantos example. This is quite easier. This is simple, quite easy to understand. It's simple to easy, simple. This is much more simple to understand. Okay, so let's take some complex example. So here, what are actually doing here? We have calculating here probability of our observed value. We are calculating here probability of observed value with assumptions of our null hypothesis. So it is simple, very easy to compute. It's very easy. Compute. So let's try some more complex example. Let's try some more complex. So let's take, this is the example 2 that we have going to discuss. So let's take example. So first we have to remind what is our task in the example. Suppose let's take, so it is better to clarify our tasks. So the tasks that we are going to, that we have to do, the tasks is, we have, suppose let's take, we have two cities. Suppose let's take, we have two cities. Suppose let's take city 1 and another city 2. And the tasks that we have to do, we have to determine if the population means of the height of the people in these two cities is the same or not. That's the task. That's we have to do. We have to find. So we have to determine. We have to determine if the population mean of the heights of the people of these two cities. People in these two cities two cities is same or not. That our main task that we have interest to, same or not. That is the job that we are interested to find. So if you write these things in, suppose let's take the mean of these people, height of these people is mu1. Let's take its mean is mu2. Suppose let's take the populations of this, of the city 1 is 1 million. Okay, so suppose let's take its population. Suppose let's take its population is 1 million. Suppose let's take its population is 5 million. Suppose let's take 5 million. So now the questions occur into our mind that there have 1 million, 5 million, in some cases there are billion of peoples in one city or major cities. So in such scenarios, so to calculate the mean means to calculate, to find the individual height of the peoples. So it is totally impossible. So in such scenario, if you have kind of peoples, if we have some kind of peoples, in such scenarios, since city 1 and city 2 has millions of people, since we have millions of peoples, it is impossible. The problem is like it is impossible to calculate the population mean. It is impossible of these two cities. It is totally impossible to calculate. This is the main problem that we have to face. This is the main problem that we have to face here, because we have a million. So calculating the height of the individual peoples is not possible in general. It is not totally impossible. So how will find this mean? How will calculate this thing? Now let's try to. So the experiment that we have to do here, the experiment. First, let's design the experiment, because it is totally possible. So actually, what is actually we have to find? Actually, the job is that we have to find the mean mu1 and the mu2 are the same or different. Same or different. That's the main task that we have to that we have to find. It is total difference or mean. So instead of it, because these things we have problem, because these are the problems to find these things. These are the problems for this mu1 and mu2. So instead of, the solution is here like that. The solution is, instead of using the population mean here, instead of here using the population mean, we used here, we used the sample mean. Okay, these are the population mean, these are the population mean, these are the population mean. So instead of using the population mean, we will use here the sample mean. That's the concept. Now let's first design the experiment. What are we going to do? So in the coin toss example, if you remember, we will doing the flip, how many times we flip the coin, and we count the number of hits, how many times the hits occur, and according to the basis of that, we will calculate the p value. Just if you remember this thing in this video. So now in this case, how we will design this thing? Now let's try to understand what is will be our experiment of this. What will be our experiment on this in this case? So in this case, we have, so let's we have two cities. We have city 1 and corresponding city 2, corresponding city 2. So for city 1, from city 1, first we have to do, we have to randomly selected 50 peoples. Okay, it is not a hard task for a city 1. For selecting random 50 peoples, it's totally easy. Anyone can doing these jobs. So we can randomly selected 50 peoples from city 1. Suppose let's take randomly selected 50 people. Suppose let's take on the city's height is h1, for 2, for second people it is height is h2, for third people is height is h3, for fifth people is height is h50. Suppose let's take the same things also doing for city 2. Suppose let's take, we have picked up 50 random people from city 2, random people from city 2. Suppose let's take the height for this city is h1 dash, h2 dash, h3 dash. Suppose let's take height is h50 dash. Suppose let's take. So this is the sample. These things are the sample height. These things are actual the sample height of 50 peoples. Sample heights of the 50 peoples. Okay, this is the sample. Same things also here. So how we calculated its sample mean? The simple thing for this CT1 we will calculate it. Suppose let's take, we will calculate it by using the simple mean formula. Suppose H1, H2, we will sum up H50 by divided by how much people we have, 50 peoples. So suppose let's take, instead of using the population mean, suppose let's take its sample mean for this CT1. Suppose let's take its sample mean is mu1. Suppose let's take, don't be confused, this mu1 and this mu1 totally different. This mu1, this mu1 totally different. Okay, this is the sample mean. These things are the sample mean for CT. These things are the sample mean for CT1. Similarly also we can easily calculate this value for this mu2. This value will be h1 dashed, h2 dashed, h50 dashed. So this value will be simple, the sample mean for the CT2. Sample mean for the CT2. That's the job. Suppose let's take as an example, means this value is what? This value is the observed value in one language. In another language we can call these value are the observed value. Observed value of CT1, this value of the, and the same things also here, observed value of the CT2, of the CT2, that is the observed value. Now suppose let's take for easier of a calculation, let this sample mean is, suppose for this CT is 162 centimeter. Suppose let, and the sample mean for this CT2, suppose let this CT2, let the sample mean is 167 centimeter. Suppose let 167 centimeter. Okay, now first the thing that we have to calculate the test statistic. Now first the thing that job do you have to calculate the test statistic. Test statistics that we have to calculate it. Okay, so what will be the test statistics for this experiment? For this experiment means we have to find that there have a difference of the population mean or not. This is the main job that we have to do, that always we have to mind these things. So according to the base of our task means we are interested to find the differences of the mu2 minus mu1. If you interest, you can easily calculate mu1 minus mu2, but for simplicity just take this thing, or instead of using the modular sign, just take, for simplicity just take this thing, mu2 minus mu1, means this mu2 is the sample mean, this mu2 is sample mean, difference of the sample mean to observed value, these things. Suppose let's take this value is, suppose let's take, we got to here x. So what is for this example, so what we will get? So these things will be 167 minus 162 semi, so 5 centimeter. On these examples we will got this value, we have got this value on this example, 5 centimeter. Suppose let's take this value is 5 centimeter, that we got these things for sample mean, these things as the sample mean for the CT2, this is the sample mean for the CT1. CT2, this is the sample mean of the CT1. Okay, that's the thing. Yes, sample mean. These things are the sample mean. Now, first we have to design the null hypothesis. What will be the null hypothesis here? So the null hypothesis here it will be is not there have no difference in the population mean of these two treaties. The first null hypothesis is there is no differences. There is no difference in population. There is no difference in the population mean. This is the first thing, but we have find the difference of the sample mean because it is impossible to calculate the population mean for these two cities. So in this for experiment, for designing the experiment, we have taken the sample mean, but we have assumed that there have no differences. This is our assumptions. This is and one in another language these things you can call this is the assumption. This is the assumption that there have no difference. For null hypothesis means this is the null hypothesis. There have no differences in the population. Just remind this thing. This is the population mean that I have taken here. Just mark this thing. This is the population mean. But in our experiment, we have taken the sample mean. Okay, that's the main thing. That's our assumption that we assume. Now that we have to calculate it here. That we are interested to calculate it here. We have to compute. That we have to interest to compute here. What we are interested to compute a probability value of the value x means these sample differences. These differences. What will be the probability value that our test statistics that we have designed on our assumptions in null hypothesis assumptions on the basis on when we have some assumptions means if you write this thing in English, what is actually meaning in literally meaning? So this means the differences in sample means with sample size of 50. Differences this means I am talking about this means differences in sample mean difference sample means with sample size with sample size what with sample size of 50, and these things are the simple assumptions. This is the simple thing of it is our assumptions. Okay, now try to understand these things in more details in English language. So if you just try to understand these things in English, if you combine these two things, then these things can be written in this English language. So this means the probability of observing a difference of probability of observing a difference of 5 centimeter in sample mean we have to find the probability of observing the difference of 5 centimeter in sample mean sample mean height. Sample mean means sample means of heights of sample size. What is our sample size? Of sample size 50 between city 1 and city 2 if we have some assumptions. If the assumption is what? If the assumption is if if there is no difference, if there is no population difference, and there is no population difference in mean heights. In mean heights. That's the thing. That's the actually literal meaning in English. If you write this thing in English, means this is the simple probability of observing the difference of 5 centimeter. Means we have observed these things in sample means of height of the sample size 50 between the two cities C1 and C2. If there is no population difference in mean heights, if there have no any difference in the mean heights, this is the simple probability definitions of the probability. Now there may occur on such situations, there may occur two cases. So in case 1, this probability value, if we find this probability value on the assumptions of the h naught, if we find this probability 0.2, suppose let's take 0.2 means what? 0.2 means 20%. If we find this value, means this value is greater than 5%. In typically we will use this 5% as a rule of thumb. Typically we use these things. This means what? This means there is a 20% chance. This means there is a 20% chance of observed of chance of observations, a difference of observed, there is a 20% chance of observed a difference of 5 centimeter. This means that talking about means this is a 20% chance that the observe a difference of 5 centimeter in two sample heights, in difference 5 like into sample means sample mean heights. I'm talking about sample heights means single sample mean heights. Sample mean heights of the CT1 and CT2, C1 and C2, with sample size 50. With sample size 50, if there have no any population difference, if there is no population difference, population mean differences, that's the actual literal meaning of this case. So in such situations, it's the greater than of our main significant level. These things actually the significant level. These things are actually the significant level. Okay, this is the actual literal meaning of this thing. So in these situations, if these things happen, then our assumptions must be correct. So that implies that on such situations, our assumption must be true. Means there have such a larger amount of probability. This one means our assumptions must be true on such cases. Okay, that means we accept the null hypothesis. As means here we accept the null hypothesis. Means there have no differences on the population. That thing we have, that we can consider here. Now let's discuss the case 2. Now let's discuss the case 2. Case 2, what is actually case 2? Let's try to understand what is case 2. Case 2, if suppose let's take, we got the probability value, probability of x is equals to 5 centimeter on the assumptions of a null hypothesis. Suppose let's take, we got this value 0.03, means 3%, 3%, we got this value. Okay, if this means what, if this means the observation probability of the observation value, this is simple observation that we observed from our sample mean, on the assumption of the null hypothesis that we assume here, this is simple 3%, this is simple 3%, and this simple 3% means this is a small value. This one is the small value, and small means is less than of our significant level. 5% is our actual what, the significant level. Which is less than significant level. So in such situations, this is the sample p value that we have. This is the p value. P value, that means our assumptions, this is a sample low probability, this value is so low, so small, so here assumptions is incorrect, must be incorrect. Here our assumption that we assume that our null hypothesis is true means there have no some differences on the population means, there have no differences, that our assumption must be incorrect. Must be incorrect. Okay, that means what? That means we reject. That means we reject the null hypothesis. Alternatively, we will accept the alternative hypothesis. Means there are some differences on our population if this thing happens. Okay. Now in next video, we will try to calculate how to calculate these things by using simple, how to calculate this p value by simply using the resampling and permutation test. Okay, from this example we try to understand these things through through this another example, population mean. Now in next video we will discuss the same example, but we will try to find the p value, we will try to find this p value to the resampling or permutation test. We will see this thing in the next video. Okay.